Hi everyone, welcome back to Life Technologies YouTube channel and thank you for watching. So in our last episode, we discussed how to implement in the AS BGP MPLS IP VPN option C. Remember this, the most preferred and the most scalable solution for the service provider network that span multiple autonomous systems. So we have the same topology or the same lab setup that we used for our option A, option B, and option C. And you can see that we have two service provider autonomous systems. We have S200 and S100. In S100, we have three routers. One router is acting as our ASBR, and we have a provider router and a provider edge router. So in S100, we are using OSPF as our IGP. Remember, with the service provider networks that span multiple autonomous systems, you can use different IGP protocols within the autonomous system. So we are using OSPF in S100 and we are using ISIS in S200. We also need to configure MPLS and LDP in S100 and S200. Remember, we are doing label forwarding and not the traditional IP forwarding. So with option C, we have mentioned that, let me clear this. With option C, we have mentioned that we are configuring BGP label unicast between the PEs and between the PE and SBR and also between the SBR. So we have BGP label unicast between the PE01 and SBR01. We also have BGP label unicast between SBR02 and PE02. We also establish BGP label unicast between the SBR so that they are able to assign labels for the route that are learned via BGP. So between the PEs, remember with option 1, option C solution 1, we are establishing VPN v4 peering between the PEs. So that's why we have an eBGP, the MP eBGP VPN v4 peering between the PE routers. Then we have different CEs. We have two VRFs that we are using to simulate. So we have VRF1. So we have C01 and C02 in VRF01, and we have C03 and C04 in VRF02. So these are simulating the customers on our network. Remember, the main objective of this lab is to ensure that customers in the same VRF are able to communicate without any problem, but customers in different VRF should not be able to communicate. So this is the setup, and remember, if you have missed this episode, our last episode that we discussed how to implement this solution 1, you can go back and watch the video, then you can come back and watch now how the packet flows on this network. So with option B, we mentioned that this is the setup for option B. You can see the packet flow. We don't have an end-to-end inner label that is being used to transport traffic on our network. So you can see that there is change in labels. When you are having, the pen is still active, so you have an inner label of 1325 assigned by SBR01, and the same inner label is on the SBR when the packet is being forwarded from P01 to the SBR. So we are using the same label. But when the packet is forwarded between the SBR, the inner label has changed. But with option C, we will see that we have an end-to-end inner label. So it's very easy to have an end-to-end tunnel with option C implementation, which is not the case with option B. So when we go back to our option C, you can see that we are having an IP packet coming in from C01. So he sends an IP packet to PE01. PE01 receives an IP packet from C01, and then it assigns two labels. We have an inner label and an outer label. So this outer label is just used to transport the packet on our service provider network. So the intermediary nodes will perform the swap operation, swap and then swap the outer label with the label they have received from the upstream router. But the inner label remains the same. You can see that when this PE01 is sending the packet to P01, it has attached two labels. We have 1026, our outer label, and 1145 as our inner label. So P01 receives a packet with two labels, the inner and the outer label. P01 will perform swap operation for the outer label, and you can see here we have outer label. The inner label remains the same, 1145. So the inner label is never touched until the packet arrives on the remote PE. So P01 will perform a swap operation, replace 1026 with 1135 and send the packet to SBR01. SBR01 receives a packet with two layers of label. It does the same, performs a swap operation and replaces the outer label. Swap the outer label that is 1535 with 1539 and forward the packet to SBR2. So SBR2 also receives a packet with two labels. This is 1539 and 1145. So SBR02 also performs a swap operation and replaces 1539 with 1045 and forward the packet to P02. P02 in this case is our penultimate hop, so it removes the outer label 1045 and forwards the packet with just inner label 1145 to P02. So P02 will perform the pop operation and remove all the labels from the packet and forward the IP packet to C02. So this is how the packet is flowing. We are coming from an IP packet to an MPLS or a label packet with two layers of labels, stacked label, and the inner label is the same across the different autonomous systems. So we have 1145 as our inner label all the way from PE01 to PE02. So we have maintained the inner label on our MPLS network. So this is how the packet has flowed from IP to MPLS back to IP. So this one we can verify it in our lab. I will discard the drawings and we can do a ping, a continuous ping between the from C01 to C02 and do a packet capture just to verify that we are getting these labels correct. So I will log into, remember our protocols are working okay already. We have the routes. So from here, you should be able to verify that we have routes from the remote CE router. And I can do a continuous ping. We need to source the loopback IP. And then I will count 1,000 packets. And we are pinging to 8.8.8. So that is a continuous ping. We can start doing our packet capture. So I will do a packet capture at this just to verify that we are having an IP packet. And I will filter ICMP. So we have an IP packet that is coming in. You can see that all these are IP packet. We don't have any label information on the packet. So from here, that is the IP packet that I've mentioned already. You can see in our diagram, we have an IP packet coming into PE01. On PE01, we expect to have two layers of packet, two layers of label. Those are the stacked label, one inner label and one outer label. But then when I was doing this lab, I realized something unique. So I will stop and start another capture at this point between P1 and P1. So there is something that I'm also trying to understand and troubleshoot. And if you have, maybe you have done a similar implementation and you understand why we are having 3 layers of labels at this stage, because we only expect 2 layers of label. assigned by P01, but you can see that we have 3 layers of label. So this is something that I'm still trying to debug and try to establish why we have 3 layers of label. We expect 2, only 2, but we have 3. So yeah, if you have a clear understanding, or if you have done the similar implementation and you understand why we are having 3 labels, feel free to leave a comment in our comment section. And yeah, I'm still also trying to understand it, and I will be back with a clear explanation on why we are having 3 labels. But we only expect 2. With option C, we only expect 2 labels, the inner and the outer label, as indicated in the diagram. The inner label should remain the same end to end. So we have 1145. You can see in this diagram, in this packet capture, that our inner label, okay, it has already changed. So we have 1158. We expect the same 1158 at the end of this setup. So here I will change it to 1158. 1158 is our inner label. So when we have 1158, we can do another packet capture between P01 and SBR01. So I will close this and also close this, we don't need it, and do a capture between P01 and SBR01. So at this point, we also expect to have 2 layers of label. The inner label should remain the same. So you can see that this is still the same, 1158. So we have an inner label of 1158. This is the most important, 1158. The outer label will keep changing. So you can see that from P01 to SBR01, we have 2 layers of label, the inner and the outer label. So we can move to the next point and do a packet capture between the SBR. So we also expect 2 layers of label. The inner label should be the same. So I will do a capture here. We expect the inner label should remain to be 1158. You can see that this is a reply. We need so you can see here we have 2 layers of label. We have the outer label 1544, and our inner label of 1158 still remains when the packet is being exchanged between SBR01 and SBR02. So that is clear. We still have 1158 here. The outer label, I've mentioned, it will keep changing, 1158. So the packet is now on the SBR, it's forwarded to P02. So on P02, we expect to keep the inner label, but the outer label will also change. So we can do a packet capture between SBR02 and P02 and see the contents of our packet. So I can do this. You can see that yes, we still have the same inner label, 1158. The outer label is now 1045. So between the two, we have 1158 as our outer label, as our inner label. So on P02, I've mentioned that this is the penultimate hop, so it will remove the outer label and only forward the inner label to our provider edge router 2. So I can do another packet capture between P02 and our provider edge router 2, and we expect to get just one label, which will be 1158. So at this stage, you can see that we only have one label, 1158, and that label is the bottom of a label stack. So it's our last label. We have popped the outer label, and now P02 will determine where to forward the packet based on the inner label. So you can see that we only have one label, 1158. So we have maintained the same inner label when we are forwarding the packet across different autonomous systems. So once it's on the P02, it will pop the outer label, and now forward an IP packet to C02. So when we do a packet capture between the two, we expect to see only an IP packet between P02 and C02. So you can see that here we only have IP packet, we don't have any label information on the packet. So as we have discussed, we have an IP packet coming into P01. The IP packet P01 performs a push operation and adds two labels, one inner label and an outer label. But as I've displayed on the screen, I end up having three labels, which still checking why I have three labels. And if you are familiar with it, maybe you can leave a comment and let us know why we are getting three labels. So P01 adds two labels and for the packet to P01, P01 does a swap operation for the outer label and for the packet to SBR01. Similarly, SBR01 does a swap operation and for the packet to SBR02. The inner label remains. SBR02 also does a swap operation for the outer label and for the packet to P02. The inner label also remains. On P02, it is the penultimate hop, so it pops the outer label and forwards the inner label with the IP packet to P02. So P02 will perform a pop operation and remove all the labels, and then it will forward the IP packet to C02. So this is how the packet is flowing from when we are having option C implemented on our network. So in our next episode, we'll be looking at how to implement option C with route reflectors, or maybe it will come later in the upcoming videos. So stay tuned and please subscribe to our channel. And if you have any question, feel free to leave it in our comment section and we'll be glad to clarify any issue that you are having when you are doing this lab. Thank you.